Alya, last time you showed me how coding can make data analysis easier, but I still feel like there is so much more to learn.
Of course, now that you've got the basics, let's take it a step further. Let's explore how we can use RStudio for meta-analysis and Bayesian Network Meta-Analysis.
Sounds fancy, but is it going to be complicated?
Not at all. I'll walk you through step by step. Once you see how it works, it will make so much sense. First thing first, RStudio is like our research workspace. We have different sections that keep everything organized.
Like what?
Well, we have first, script editor, on the top left where we write our R code. Second, console, where the code runs and results appear on the down left. Third, environment pane, keeps track of all our data and variables on the top right. Fourth, plots pane, where we visualize our findings on the down right.
So, everything we need is in one place. Nice!
Now, let's see how we actually write and run code in RStudio.
I usually type in the console, but is there a better way?
Yes, the best way is to write your code in the script editor and then run it. Here's how.
How do I run this code?
You can run it by pressing Ctrl plus Enter in Windows or Linux, or CMD plus Enter in Mac. This sends the selected line or the current line in the script editor to the console.
Wow, that's much easier than typing everything in the console.
Before we dive into meta-analysis, let's get comfortable with some basic coding concepts in R.
Sounds good. What's the first thing I should know?
Let's start with variables. Imagine we are collecting patient data and storing their age and blood pressure readings. In R, we can store values in variables using assign code, and we use factor C to create a factor, which is a list of values, like this.
So, factor C is used to combine multiple values into a list?
Exactly. It's one of the most basic ways to store data in R.
I saw that R uses a lot of variable names. Does it matter if I use uppercase or lowercase letters?
Yes, R is case sensitive, which means patient underscore age with capitalized P and A and patient underscore age with no capitalization are treated as different variables. Look at this example.
Oh, so I have to be careful with my variable names.
Exactly. Now, let's see a case where we categorize patients based on their blood pressure levels using conditionals.
So, this can help flag patients who need follow-ups.
Yes, and if we need to analyze multiple patients, we use something called a data frame. Think of a data frame as a table, where each column represents a type of information, like age or blood pressure, and each row represents a patient.
Oh, so this makes it easy to manage structured data. So this loads our dataset into RStudio.
Exactly. Now, let's move on to running the meta-analysis.
What does this code do?
It tells R to run a meta-analysis using risk ratio, RR, as the effect measure. We are using the inverse variance method, which is a common way to estimate pooled effects.
So, this could summarize the meta-analysis result.
Yes, it provides important statistics like the pooled effect size, confidence intervals, and heterogeneity measures.
That looks great! So we can quickly see the effect sizes and confidence intervals.
Yes, now that we've done a standard meta-analysis, let's move on to Bayesian Network Meta-Analysis. To perform a Bayesian meta-analysis, we need to install and load the following packages. Read X1 for importing the data. RJAX for Bayesian modeling in JAX. And GEMTC for network meta-analysis.
Wait, I installed RJAX, but it is not working.
That's because you need to install JAX first. It's like trying to drive a car without an engine. You need to install JAX first to make RJAX work. You can download it from here.
Got it! JAX first, then RJAX.
Load the dataset from an Excel file by importing it. Now, let's build our network. Think of treatments as points connected in a web. And we want to see how they relate to each other using plot to visualize and summary to check the number of studies and comparisons.
So, now we get to do real analysis.
Exactly. We define a random effects model and let R process the data. Run the MC simulations with different adaptation and iteration settings.
How do we know if it worked?
We check our results. Then, we can check model fit using DIC_values to display the deviance information criterion. Afterwards, don't forget to assess the inconsistency in the network using node split. Estimate the probability of each treatment being the best.
Wow! So, by coding in R, we can analyze multiple treatments at once and rank them.
Exactly. Bayesian Network Meta-Analysis allows us to compare treatments even when they haven't been directly compared in studies.
And we did it all through coding. It is like having a super organized way to compare research findings.
Exactly. Research and coding go hand in hand. Now, imagine the possibilities with more practice. For further details, check the GEMTC documentation.